Hi everyone. I welcome you here in my talk. This is afternoon, right? After we had lunch. This is a time where we are getting into that deep state of, thinking a lot, right? So I hope that this is going to be interesting talk for you. Okay. This is going to be some kind of a therapy. Team therapy for us, for all of us who are working on securing production systems. And let's get. Okay, I'm doing a little intro about myself. Okay, so I'm Ben. I'm today co-founder and CTO of Armo, a small startup in the Kubernetes security space in Israel. Beyond that, I'm one of the maintainers of Kubescape, which is a open source Kubernetes security tool. I hope you heard about it. If not, you should. I'm coming from the security world. For some time, I've been attacking systems for money and for fun. But gradually went more into development in my career. And today I'm also beyond, being CTO of a startup. I'm also teaching grad and postgrad students of advanced security classes. And you can find me usually around tech security and CNCF or the CNF working group. And that's all about me. And Armo, as I told you, is a Kubernetes security startup. We're small, but very strong and very interesting. So look into what we are doing, and especially Kubescape, if you're working with Kubernetes. But let's get into this talk. So quite a lot of people came here, and I just want to do a short survey here. Who is doing vulnerability scanning? Can I have your wow? Awesome. So you came for a reason, right? Who hates it? Yeah, me too. So why we are doing vulnerability scanning? Okay, so obviously, depending on many things, but either we have in our organization, we have a CISO who's in charge of the security posture of the production system and the internal systems. But we have something in our company, in our organization, who is saying to us, okay, guys, we have to know what vulnerabilities we have. Just go and scan it, okay? And at the first, at the first sight, okay, we're asking why. And I can be sure that in more than 80 or 90% of the times this question is being asked, the answer is compliance. Okay, anyone who did, I don't know, SOC 2 compliance. We are in Europe, so we might think about other compliance, not just SOC 2, but I'm sure that you know better what SOC 2 is than me. Okay, it requires you to monitor your vulnerabilities. It doesn't say that you have to fix it. You have to monitor it, which is interesting. Why? And this brings us to really why we are doing it. Okay, so we have this infinite loop. Okay, infinite and annoying loop. Okay, of scanning for vulnerabilities. Then we have a list of vulnerabilities, and in theory, what we should do for each vulnerability is we should find a fix, if there is. And apply this fix, because usually in our systems it's not like our iPhones or Android devices where the fixes are being pushed to our device. We need to be pushing the fixes, and if we don't have a fix for it, we have to think we might want to minimize the effect, okay, of the vulnerability. So, and honestly, okay, both of them takes time, okay? Finding a fix, if there is one, and then applying it, releasing a new version, putting it into production, obviously before then doing some tests. And the same goes for minimizing effect of vulnerabilities, which is really hard, which is something that's not defined, and usually this is something you have to do with a security department saying to close some port for an access or something. But it's a hard thing, right? And the question is, okay, that if we want, okay, if we need this loop, okay, and we are scanning vulnerabilities for vulnerabilities, right? We're using different vulnerability scanners, which in a few minutes we're going to talk about them a little bit. But we are also being asked sometimes to have an external company coming to us and doing penetration testing from the same compliance department. And the question is, what is the difference? Okay? But I have to tell you that penetration testing is usually a manual work. Even myself, as in my previous, titles, I've used to do some penetration testing like 10 plus years ago, and we did a hell of an automation around it. But it's still a manual work. It's manual labor. It costs a lot of money, and in theory, we should have a very, very good sense of what vulnerabilities we are having in a production system. But it is expensive, takes time, and if we are, we are trying to remember, okay, why we are here. Not just here today in DevOps, but as DevOps engineers and automation engineers, we understand that there is no way in the world, okay, that you can automatically do penetration testing at a high level and a higher quality. So therefore, penetration testing is not really covering, okay, what we are trying to achieve here, in the sense that it is not viable. And now we're talking a few minutes about what is vulnerability scanning. And right now I'm going to limit the talk only to image vulnerability scanning, okay, because the sake of the simplicity, but it's more or less the same for if you're scanning for vulnerabilities on a virtual machine as well. So how is a vulnerability scanner working? So it needs two things, two major parts. One is it has to be able to find out or to list, okay, what kind of software you have in your container image, okay? It's if you have a list of software, okay, if you know what you have in your container, okay, this enables you to start to look for vulnerabilities. Why? Because you have the other part, which are public databases, which are publishing information about what kind of software was reported with a given vulnerability. Okay, we'll call it vulnerability database. Okay, so what the vulnerability scanner does is actually combining these two tables. Okay, what kind of software do I have? Together with what are the general vulnerabilities software packages are having, and they are crossing this information, aggregating them into single one list where you are getting a list of vulnerabilities. Now, I might, kill the punchline, but there is already a question here, okay, that any kind of vulnerability I'm going to find here has to be in some kind of public vulnerability database, right? So, in other words, if a given vulnerability is not found in a public database, or for some reason I'm not able to list a given software package during the scanning phase, then I will have my list, the end list is going to miss some of the important things. But let's just go on for now. Okay, so let's talk about the basic package discovery. So, actually the list of software you have in your container or in a given other software or a package or in a VM, we call it SBOM, okay? Software Bill of Material. And the bad part is that container images are not coming with software bill of materials. Okay, this format has been standardized, even not once, which is kind of funny, because if you have two competing standards, then you already have problems. But nevertheless, the way we are building container images today, we don't require the supplier of the container image to come with a software bill of material. This means that we need to create one, and this is the first part of the image vulnerability scanning. How can we create one? So, right, usually our container images are based on some very nice Linux base image, some I don't know, Ubuntu, CentOS, Alpine, and so on. This means that there is a package manager inside the container image, and every package which was installed with this package manager, okay, has been listed inside the container. So every package manager needs to write the actual installed packages on the file system. Okay, right? The package manager doesn't know that it's inside the container, right? It's the same package manager as we had like 20 years ago or 30 years ago even. It needs to write that if I'm installing, for example, GCC inside the container, it needs to write that GCC was installed and GCC is made of the following 10 files, right? Because this is the only way a package manager is able to manage this package afterwards, right? After the installation, if I need to uninstall the package manager needs to know what this package is made of. It has to know that this package was installed and how to remove it or to update it, which files needs to be affected by it. And therefore, we have a list inside the container image, which actually contains, okay, part of our SBOM, okay, which should be fine, great. Is it enough? Yes or no? No. Yeah, otherwise we'd stop here, right? So, so there is a very basic problem with it, okay, with this approach, that it's not enough. Okay, it's a beginning, but it's not enough. Why? Because any kind of package, okay, any kind of software which wasn't installed with the Linux package manager, okay, is not listed, okay, inside those logs I was talking about. And a great example of it, okay, is any kind of software, modern software specific language specific packages which we are installing. So right, we are installing things with Python packages. We are installing Java, and we need also to look at them. So we have to find out if there is a Python in the environment and find its files inside the container files. Okay, and the nice part of this is that usually modern package managers of these languages like Python. Or also like Java, okay, are neatly containing names of the packages and their versions. Okay, there are other issues with them. I'm not going to go inside. I'm just giving you a hint. Okay, also that what if these packages are also pulling other non-Python packages inside the container, which I've seen a few examples of it, but we're not going inside because that's a little rabbit hole. But we can also, this way, if the scanner who is trying to create a list of software inside which of the container is made of, okay, can look up after these files and list them, okay? And you also have the same for Node. And in jar files, you neatly have the metadata file inside, the jar. We know that jar files are just simple zip files inside. And we can find this information inside. And now we are asking, okay, is it enough? Are we happy? And you're going to answer, no, right? No. Okay. So there are components which simply doesn't have metadata as of today. there are, think about, and I'm going to give you here, few examples, okay? Think about, your own software. If you are an organization and you are packaging your software, your Python software inside egg files or pip installable packages, good for you. I'm really happy. But you are the few, okay, if we are looking around the world, okay? The same goes for, many other options. And as a first rule, okay, I have to tell you that usually the highest layers of container images, which are containing own applications of an organization, usually contain software which doesn't have package information. But that's not really, you will see that that's not just the only problem, okay? But I have to tell you that in general, if vulnerability scanners are continuing this approach of generating SBOMs, and we are going to, most of us will keep neat software packages, and we'll take care of only putting good software packages inside our containers, okay, with listing and metadata, okay. This is not that bad, okay. But you have to know that there are issues here. For example, the simplest, I can tell you today that Go applications, is there a way that from a Go application, a single executable, we can decide what kind of software package Go modules went into that Go package? No. Okay, if you have a Go mod file, you can, but without it, you have real problem here. So it is not easy. Okay, so an SBOM example is I just brought it here. Okay, just for the sake of giving you a small taste, you can see here that there are artifacts in the SBOM, which is actually the packages. You can see here that there is the adduser package, which wraps around the adduser command in Bash. We all know it is a deb package. It's Debian. It was a Debian file, and who found it was a DPKG cataloger, which is looking for actually the things which were installed by the DPKG. And you can see that list of files it contains and in which container layer it can be found. Okay, maybe a license and so on, but this is the main thing you have to understand. Now, going over to the other part of what the vulnerability scanner is doing. Okay, so today every respectable Linux vendor is publishing a list of vulnerabilities its packages has been reported with. Okay, so there, if you go to this link at debian.org, okay, you can literally download all the CVEs which were reported against packages which Debian is publishing. Okay, which is awesome. Okay, it's hard to maintain, and you can ask the guys there over, okay, how much time they are spending with this, but they are doing it. Okay, and you can download really this database, which looks like, in the table I showing you before. You see the name of the package, like Bash, the version, and the actual CVEs. Okay, the vulnerabilities it contains, and obviously, okay, every CVEs, and I'm not going inside right now, but I think because most of you already are doing this, you know that every CV has a number, has a description, attack vector, severity, okay, and mostly it's made of of this information. So this is what you can download. Now again, if we are returning to this previous discussion, okay, this is only vulnerabilities of the packages which were released by the Linux distro maintainer. Okay, if it is not, if we are using a pip package, okay, which is not coming from Debian, okay, we have to look elsewhere, and you can see today that GitHub has, is trying to fill in a vacuum here, and going inside and releasing vulnerable information about packages, about projects which are maintained in GitHub. So if you're an open source maintainer and you have a package, a project inside GitHub, and someone comes to you and tells you, man, you have vulnerability in your software, which were already delivered to users, you can come back to him and say, okay, I'm going to allocate an ID for this vulnerability. Go to GitHub and ask for a place to report these things. And through this, vulnerability scanners can also retrieve vulnerability information for GitHub projects. But that's not just the only one. Okay. You can, I don't remember if I put here. So you can see also that Google is partially maintaining a huge list of vulnerabilities in packages, which is also publicly available, and you can download it. I heard that also Amazon is trying to go into this. So there are multiple parts, where we are taking this information. But again, remember, that these vulnerabilities are against. These databases are mostly against open source projects. There are obviously vulnerabilities available for closed source projects, and they are maintained usually at the vendor level, which is quite hard for vulnerability scanner to go after every vendor and look into their databases. Therefore, I think that we're going to see here an evolution. But as a summary, there are multiple sources of vulnerability information. It really depends, on the actual software component. Whether it's been, whether the maintainer is really, putting in this into this effort. And don't forget the same thing I told you before. Vulnerability scanner will be only able to find vulnerabilities, which has been reported and publicly available. In other words, any kind of 0 days will never be will never be returned by a vulnerability scanner. And at concluding this part of the discussion, if we are taking the actual SBOM, creating a list of software packages which are inside the container image, and going using these image package names and versions, going after all the vulnerability databases and cross-checking them against them and seeing whether these vulnerabilities have, whether these software packages has vulnerabilities reported against them, enables the vulnerability scanner to create a big list, a huge list, right? It is simply sometimes overwhelming, and one of the reasons, for this talk is actually this. We're going to talk about what we can do with this overwhelming result. So I did, some, when I created this talk, in order to show you just how I think the problem is deep, I scanned a few components of our own production system. For example, we've just updated our Elastic to 7.17.3, which I think, if I'm not wrong, this is the last in the line of version 7 Elastics. And you can see up there that, without, the latest release, as of, a month ago, already had 10 high vulnerabilities, 73 medium vulnerabilities, and 39 low vulnerabilities. In our production Grafana, I saw 9 critical vulnerabilities, 22 high. In our the kubeproxy component of EKS 1.20, which I acknowledge that this is not the latest kubeproxy release. But I think that those who are using EKS has a good chance of having, Kubernetes 1.20 running. Has 13 critical vulnerabilities. So I said, just let's go a little bit forward. Maybe I'm behind, the release schedule of Elastic, and it turned out as opposed to the Series 7 Elasticsearch, okay, the Series 8 Elasticsearch had 2 critical and 19 high vulnerabilities. The Grafana 23 had 3 critical and 8 high. None of them is patchable. Okay, there's no, these CVs doesn't have a fix available. Okay, and you know this obviously makes us think. Okay, what can we do? Okay, because on the one hand, okay, we are trying to make sense of it. We are scanning because we were told to scan okay, these images. Okay, we are trying to protect the system, but in general we are dealing here with the kind of shock of this understanding. What can we do with this information? If the latest Elasticsearch, I'm really not trying, Elasticsearch is a fantastic project, okay, don't take me wrong, okay? If latest Elasticsearch is being shipped with 2 critical vulnerabilities, okay, something is clearly wrong here, right? So, so if we are looking, trying to a little bit make sense and understanding a little bit better, okay, what's happening, okay, inside. You know, every one of us who started, okay, I'm not sure. Okay, is there someone here who started the containerization world without Docker? Anyone? Before? Maybe, yeah. Good to have you here. So the way Docker invented the way of building images has an inherent problem, okay, right? Because, you know, containers, images are built on inside containers, okay? So in order to do something inside the container, to construct, even to do the smallest thing, right? So in order to call to chmod, okay, and change the permissions to a file, I need to literally copy the chmod package inside the container during its build. And there is no automatic way to remove it, okay? It's an incremental build, and after, you know, I'm doing step 1, step 3 inside my Docker file or container file, I'm doing these steps, and then I say, well, okay, what I got here, I want to tag, okay? This is the results of my build. This is the container image. In other words, everything, okay, in the lower layers inside a container is usually not application related packages. They are mostly packages we are related to the way I'm trying to build my container. In other words, if I want to, inside the container, and I'm returning to my previous example, if I'm trying to, you know, doing a chmod, I need a package manager, and then with the package manager, I need to install chmod inside the container. And it means that I'm going to, even only if I'm, you know, very knowledgeable and very advanced user, I'm going to start to delete, you know, files from lower layers. But in general, I'm going to, my container image is going to live with that chmod forever, and it's going to be copied everywhere where this container image is used, despite there is no real use during the application runtime. Okay, and therefore they are somewhat misleading. Okay, the vulnerability scanners. Okay, because there are a lot of, sorry for the word, junk. Okay, inside the SBOM and inside the results, which are actually, you know, packages which are inside the container image, but they have no use inside the application runtime. And we are listing them in the SBOM, and therefore we are taking them into account when we are talking about where we are looking for the vulnerabilities. But during the runtime, they are not used, and therefore, from an attacker perspective, they are not exploitable. Okay, and usually the highest layers, okay, the last layers of the container image are the ones who are containing usually the actual jar files or Python files or Go files, or which are going to make our own applications. And there is, you know, a clear problem here in you know, in a practical sense, because the container results, as I told you, are the scan results are containing everything that the container image has, it lists everything it has in the SBOM and creates the vulnerability association with all of these packages, whether they are used or not. Think about Busybox, okay? The Swiss Army knife, okay? You know, well, let's just not get ahead of self. So I'm going to show you two examples here, okay? One is Busybox and the other is libcurl, okay? These are two distinct examples. One is simpler and second is not. But I have to also want to tell you that what, you know, the scan results does not contain, okay? And we already mentioned those. These are things which, you know, the package manager or the SBOM generation does not contain and cannot discover. 0, okay, days, and usually our own code, our own vulnerabilities which we are adding. So let's take the example of libcurl. Libcurl is, I think that everyone heard about curl here. Okay, libcurl is the base library, okay, which I think that 90% of the applications are using it for HTTP and HTTPS communication. But beside HTTP and HTTPS, okay, libcurl supports a bunch of other application protocols, okay, which I don't think that, you know, I don't know if anyone here uses it for example, for SMTP, right, or Samba, but it supports it. And what it means that if someone finds a vulnerability in libcurl, in the code path of, for example, in this case, TFTP, which is a real thing, okay? I don't remember, it was within the last year, there was a critical vulnerability reported on the TFTP implementation of libcurl, okay? Nearly no one uses libcurl for TFTP, but for every one of us, okay, the counter of critical vulnerabilities has jumped by 1, despite we are not using, okay, this given feature of libcurl, and that's not an easy problem, okay, to solve. The other, you know, the other example is Busybox, okay, Busybox, which is really, you know, the Swiss Army knife, okay, of Linux CLI. And it has a wide range of use, okay, of actually incorporating a lot of functionalities from other CLI components, okay, has vast list of vulnerabilities around it, okay, but again, and I'm returning, okay, the relevancy, okay, of its vulnerabilities is not clear for your given application, and this has to be, you know, somehow you have to take into this to account. And there are simply a lot of, you know, questions around here. Okay, whether all the vulnerabilities of Busybox are relevant or not, or at all they are relevant. So it made us think, okay, in the Kubescape project, okay, because you know, during the day we are maintaining of a production system at Armo, but during the night we are writing this open source project, and it made us think, okay, what can we do? Okay, and the question was whether we can automate, okay, at least part of this decision process. Okay, whether we can automate the way to say that whether a vulnerability is relevant or not, and discover it during the runtime. So if we said that we say that a vulnerability is not relevant if it is related to a software component which is not running in runtime. Okay, it's not of the container. In other words, if we are returning to the example of chmod, okay, if chmod has 10 vulnerabilities and adds 10 vulnerabilities, okay, to my final result, if we are not using chmod, okay, I don't want to see them in the end result, okay? And at least, okay, in this way, if I can detect, okay, whether something is not relevant, something is not in use, I can remove it from the SBOM, okay, which I'm feeding into the vulnerability scanner, and therefore I can remove them from the end results. And I'm going to show you, okay, the small research we did, and a few words about where we are taking this, okay? Because we are using Redis, okay, on production system. We have scanned Redis. As it turned out, okay, Redis had 81 vulnerabilities like 4 months ago, the latest, 81, yeah, with critical vulnerabilities inside, and so on. And obviously this wasn't right. So what we did is we created with some scripting magic. Okay, we started to use strace when we started to run the Redis container. And using strace, we listed all the system calls this container was doing. In particular, okay, we wanted to know which files are touched inside the container image. Okay, which are the files which are touched and which are the files which are not touched. Okay, and we got a bunch of, and especially, okay, just, technical part. Okay, we were looking at the opennet system calls and also execv and all these specific system calls which are actually touching software components, opening them for running. What we did is we created the list, okay, of files which were touched by the container during its start and runtime. Okay, and we got a list of files, and what we did is we compared it with what we had inside the SBOM of Redis. So remember that we were talking about the SBOM. Okay, the SBOM not only contains the list of every package and its version, but also it contains the list of files it is made of, right? So I could mark all those actual packages which were used inside the container, and at the end I got the list of packages which were used inside the container, and I could say that all the others are not used, right? And I can remove them from the SBOM. So I created what we call a filtered SBOM, okay, which actually represented only the running packages. And at the end we got from 81 vulnerabilities to 11 vulnerabilities. This is the list. You can see that nearly everyone, each of them is the lowest level of severity, okay, negligible. There is one unknown, okay, and I have to tell you that there is a single high vulnerability, and we've checked it, although I have to tell you manually, and it was clear that this is not a relevant vulnerability for the same reasons I told you about the libcurl and TFTP. Like it's a vulnerability which is not affects the Redis. So actually we went automatically from 81 to 11 vulnerabilities, and I think we spared for ourselves a lot of time. And again, okay, we start to think of, okay, how we are doing automation around this, okay? Because strace and script magic is not really good for automation, and as you can see from from Alex's tweet, okay, Alex Jones, okay, then there is, I think, no new project around security these days who are not trying to use eBPF somehow, okay? So we became this guy who was wandering around and saying, bro, are you using eBPF? And said, okay, we can try to automatize this, okay? And what we did is inside the Kubescape project, which contains an operator which you can install into your Kubernetes cluster, and it creates a constant scans of your container images inside the Kubernetes cluster. We added a new component, okay, which is based on eBPF. It's a node agent, and what it does, when it sees a pod with containers starting on a Kubernetes node, it starts to record its file accesses. Okay, it needs obviously rights to run eBPF, but we've taken the base libraries from the awesome Falco project of streaming, all this file access information on the node. This node agent records, if I recall correctly, okay, the first 10 minutes of activity of a file activity of a container and stores them. And when the SBOM becomes available, okay, during the scan for the image, it creates, it creates this filtered SBOM just with the research, and feeds this filtered SBOM into the vulnerability scanner. So what it means that we are trying to automatize and creating open source product of this idea, okay, of somehow getting over this CVE shock by removing these issues and inside this project, we really I'm going to be honest, this is really the first steps, and we are going to release this month, something around KubeCon, which is going to be in 2 weeks. We're going to release the first version. We are going to show it in tech security, and obviously we'll have issues, and there are several usability questions around this, as how you're going to propagate this information and so on. But in general, the idea is to change the way we are approaching vulnerability scanning, It's not enough only to look at what you have in the container image, You also want to see what's happening inside the container in order to be able to really see which vulnerabilities are really related to you and which one is not. But, in the results, I've missed here that in general, you see, actually we got to the very same results, with this idea, and as of today, if we'll try to in a few weeks, we'll try to install this as part of the Kubescape operator. You will get inside the results in CRDs in Kubernetes. So it's it's for now it's really open-ended information, and you can take it to elsewhere. But obviously, the general idea here is to create a way to filter out the irrelevant results for you. Another way of approaching this whole issue is VEX. Is there anyone here who heard about VEX? No, I thought so. So it's a pretty new idea, and we're trying in tech security. We're trying to define it and have a general acceptance for it, because SBOMs are more or less closed and agreed upon. But the other thing is that as you saw, you have to, as software maintainer, you're going to be required by the federal government in the States to provide SBOMs. But not about vulnerability information. And VX is a document format which actually enables you to declare what kind of vulnerabilities are relevant for your software package. So if you remember this example with libcurl and the TFTP, in a given case of I don't know. Redis. If Redis had used libcurl, Redis could have defined that, well, since I'm not using TFTP in my libcurl implementation, this vulnerability is not relevant for me. And VX enables you actually to take the list of all the vulnerabilities which the vulnerability scanner finds inside your container, and declare which one of those are really relevant. And what it's I think the nice part of it, of this idea, is to be able to really declare this information for everyone and make it public knowledge, and not to let every organization, every company to run after its own vulnerabilities and trying to decide which vulnerability is relevant in Elasticsearch or in Grafana and which are not. And I think that VX is a great way to great idea, to create an exchange format, where we can, software vendors, we can declare this information once for everyone and spare, do it once and use many times, as opposed to, for everyone to work on this information by itself. This is just a minor example, okay, of VX in action, but since we don't have a lot of time, okay, I'm going to skip it. So from VX perspective, I can, as a Kubescape maintainer, I can more talk about, okay, what's going to happen in Kubescape more or less. But from VX perspective, okay, this is going to be a question of the following year or two, whether this is going to be accepted as a standard of vulnerability exchange information, whether really software vendors will take the time and declare this information and make it available for everyone. And again, I'm returning to the original discussion. If a software vendor takes his time to release information, okay, about a base vulnerability, for example, Debian, then if we are building an image and publishing a container image based on this Debian base image, okay, we can theoretically with VX will be able to declare whether this is relevant or not a given vulnerability for us. And obviously, okay, the question is going to be who is going to follow. But I can tell you there is an interest, obviously, around many big companies for this, because this is a really pain point for everyone. So this is my part, okay? I want to we have 4 more minutes, and I want to leave, if you have questions, I will be happy to receive questions. If not, that's also okay. Are there questions? Yeah.
So you check which files in the container are accessed, right?
Right.
But how do you know that there's not some part of obscure functionality that isn't hit while your test was running, and therefore a certain file is not touched while it would otherwise be accessed?
Oh.
And then it's filtered out.
So it's a great question, okay? And I'm trying to rephrase it, okay? So the question is, think about, sorry guys, I'm returning again to Elasticsearch, okay? I'm stuck with it. But think about it, Elasticsearch has 2 running modes, right? Single node mode, right? Where it is some kind of a development, you can bring up a development instance of Elasticsearch, and you can bring it up as a master or a data node or ingestion node and so on. And as you said, there might be, depending, the same image, okay, incorporates all these functionalities, and in one time, okay, it touches a file, another it doesn't, right? And I can tell you that as right now, okay, and the same applies for the VX, not just for our Kubescape project, that VX is also trying to combine these configurations into these declarations. So if I'm declaring, okay, that there is an Elasticsearch image, okay, which has XYZ vulnerabilities, I need to declare in what kind of configuration I have run it, and maybe for how long, right? Because without that, okay, obviously, and you're completely right, okay, we're going to miss out we might miss out some of the vulnerabilities, because it's in a single node mode, I'm going to see these vulnerabilities. In master node mode, I won't see it, okay? If I'm really trying to propagate this information from the master node to the single node mode, okay, I'm going to miss out on things. So obviously, you're right. If you want to declare relevancy, you have to declare with what kind of environment you achieve this information with. Yeah? Yeah, sorry?
Are there already tools so scanners that use this VEX information?
No, not yet. I have to tell you that as of now, VEX has not yet been finalized. It's in the middle of the discussions, because exactly, I think the major question is exactly your question was, how am I declaring this relevancy information? In what kind of configuration I can take into account here? Okay, and this is where we are standing right now. And if you're interested in, okay, you're welcome to join the CNCF Tech Security meetings, and you will hear a lot about these discussions, and you're more than welcome to contribute. Yeah?
Is relevancy, is it like an on-off switch, or is it like a threshold? So amount
So as for now, it's an on-off switch, okay? You can enable it, okay? You will be able when, like in 1 or 2 weeks, we'll release it, you will be able to enable it. You will see all the vulnerabilities and the filtered vulnerabilities.
Because if you would have a threshold, you would also be able to maybe define vulnerabilities that were not so critical, but you would heavily rely on. So that would also be interesting to map.
Interesting question. You're welcome to come and explain your idea. It sounds interesting, right? So thank you very much, guys. Have a nice day.